All right, I'm going to work out all 6 of these solutions using both shell and disk method. The worksheet is all about the disk method, so that's the preferred method, but I want to show you that you can use either method, and in case you set it up naturally using the shell, then so be it, then you can check your work. All right, so the first one is y equals negative x plus 2. It's going to be starting up here at y equals 2, negative 1 slope, so this point is going to be 0, 2, 2, 0. We're bounded by x equals 0 and y equals 0. So our region is right here. All right, since we're revolving around the x-axis, if we do the disk method, our disks are going to be this way. We're going to have dx. So disk dx. Volume for disk method is pi r squared. So volume is pi r. Our bounds in dx are going to go from 0 to 2. Our radius is going to just be simply y, and y in this case is negative x plus 2. I'm going to square that radius and dx. Next we're going to do the shell method. That's going to be dy. Our shells are going to look like this as we rotate around. So again, our radius is just going to be y. V equals 2 pi r h. Our y values are going to also go from 0 to 2. Our radius is y, and our height varies as a function of x. And x is equal to, add the x over to the other side, we'd get 2 minus y. So 2 minus y dy. All right, next we've got the square root of x, which looks something like this. X equals 1 is going to be there. X equals 4 going to be there. So this point is 1, 0. This point is 4, 0. This point is x equals 4 square root of 4, 2, and 1 square root of 1, 1. Our region is going to be bounded right there, and we are rotating about the x-axis. All right, so to do disk method again, we're going to have dx. Volume is pi r squared, so volume is pi. Our x values go from 1 to 4, and our radius is simply our y value, which is square root of x squared dx. Then for shell method, which is going to be dy, our shells are going to be this way. Again, our radius is going to be y. Volume is 2 pi r h. Volume is 2 pi integral. This time our y values, this one we're going to have to break up into 2 different shells. Because notice that up until y equals 1, our height of the shells are always going to just be 3. But after we pass y equals 1, our heights of the shells are going to be, a function of x. Or in this case, a function of y. We'll have to write it. Okay, so let's go from 0 to 1. Our radius is going to be y, but our height is just a steady 3 all the way up from 0 to 1. So that's going to be our first integral. Then we're going to have another integral. Our shell method is still going to be 2 pi r h. This time we're going to go from 1 to 2. Our radius is still going to be y, but this time the height of our function varies, with x. So I guess I want to think about it in terms of this distance is going to be 4, and this distance is going to be the square root of x. And if I take 4 minus the square root of, or no, that's not square root of x, that's just x. This distance to that point is just x. So 4 minus x is the height, but I can't have x in my dy integral, so x must be equal to y squared. So I'm going to go ahead and write our height as 4 minus y squared dy. All right, moving along. We've got negative 1/2 x plus 2. Okay, we're going to start at positive 2, and we're going to have a negative 1/2 slope. So this is going to be 0, 2. this is going to be 4 comma 0. We're bounded by y equals 0, or x equals 0 and y equals 0, and we are revolving about the y-axis. Our shaded region is right there. We're revolving this way. Alright, so starting with disk method, we're going to have dy disks. Volume is pi r squared, so volume is pi. Our radius is our x value. And in this case, x, we'd have to subtract 2 on both sides, and that equals negative 1/2 x. Multiply both sides by negative 2, and we get x by itself. So x is equal to 4 minus 2y. Our bounds are going to go from 0 to 2 in the y direction, but again, our radius here is just x, but we want to write that in terms of y. So that's going to be 4 minus 2y all squared dy. Then our shell method would be dx. Our volume is going to be 2 pi rh. 2 pi dx goes from 0 to 4. Our radius is going to be x. And our height is going to be, the height of our cylinders is just going to be our y value, which is given to us already in terms of x. So that's just our negative 1/2 x plus 2 dx. Lovely. All right, next one, we've got y equals 4 minus x squared. So that's a downward facing parabola shifted up 4. It's going to look something like this. Center that. And then we've got y equals 0. Okay. And then we've got x is greater than or equal to 0, which is telling us to use only the part of our region in the first quadrant. Okay, so this point right here is our y-intercept, 0, 4. Our x-intercept is going to be 2, 0. We're revolving around the x-axis, so we're going to do disk method first with dx. All right, volume is pi r squared, so pi, in the x, our values range from 0 to 2. Our radius is going to just be our function, which is already given to us in terms of x. We're going to square that, dx. For the shell method, which is now going to be dy, volume is equal to 2 pi rh, so we're going to have 2 pi. Y varies from 0 to 4, and our radius in this case would be y, and our height would be the function, or I guess our x, this distance x would be our height. Radius is y, but x we need to solve for. So y minus 4 equals negative x squared. Let's flip-flop these, so x is equal to 4 minus y. So x is equal to the square root of 4 minus y. All right, so 4 minus y dy. Okay. Now we've got e to the x, which is going to look something like this. X equals 0, it's going to be right here. And y equals e is going to be somewhere above this point, because this is the intercept, y-intercept of e to the x, which is always at 0, 1. And this point here would be 0, e. And this point at the line y equals e means x must be 1. So this is 1, e. Go ahead and shade our region. And we are rotating about the y-axis. All right, so that way, which means if we're going to do disk method, that's going to be dy. Volume is pi r squared, so we're going to have pi. Our y values go only from 1 to e. And our radius is going to be our function, the x value. So in this case, x is not ln of y. So ln of y squared dy. Lovely. And our shell method is going to be dx. volume is 2 pi RH, volume is equal to 2 pi. Our x values vary from 0 to 1, and doing the shell method, you can kind of see that, well, we don't want to go all the way down like that. We want to do only that. Our radius is going to be x, but notice that our height is going to be this distance minus this distance, because we just want the height of the region that's shaded. So the top line is all the way up at y equals e. This line right here is our e to the x. So if we subtract e minus e to the x, that's going to leave us with the height of our cylinders. So our radius is x, and our height is e minus e to the x dx. Okay, last one. So first of all, we've got y equals square root of 9 minus x squared. That looks a little weird. Let's square both sides. So y squared is equal to 9 minus x squared. If we add the x squared over, notice that we get x squared plus y squared equals 9. That is a circle of radius 3. And because they give us y equals the positive square root of that function, it's just going to be the upper half of the circle. And then our x values are greater than or equal to 0, which means they're really just saying take this quadrant of the circle. And we're also bounded above by y equals 0. All right, revolving around the x-axis. All right, so first let's do our disk method. That's going to be dx. Gotta label these points. Since it's a circle of radius 3, centered at the origin, that's going to be 3, 0, and this is going to be 0, 3. For disk method, we've got pi r squared, so volume is equal to pi. Integral from dx, 0 to 3. Our radius is going to be just that function, so square root of 9 minus x squared squared dx. Then for our shell method, we're going to have dy. Volume is equal to 2 pi RH, so we're going to have 2 pi. Y varies from 0 to 3 as well. And notice that our radius is just going to be whatever the y value is at any given point. And our height of the cylinder is going to just be given by the x value, boom. But x we have to solve for. So radius is y, height is x. And again, checking this out, if we solve for x, it would be 9 minus y squared, square rooted. 9 minus y squared, square rooted, dy. And there you have it. So hopefully that kind of helps get the flow of things.